Alright, Math 3, we've got the rational functions review. So the first thing is to identify vertical asymptotes, horizontal asymptotes, x and y intercepts, okay? Well, the first thing we can do is we want to find vertical asymptotes. Now remember, rationals look something like this. We've got horizontal asymptotes, they never cross, and vertical ones as well. Now the way we find the vertical ones is based off the fraction and the leading coefficient. So, if we have the same degree, okay, means we have a horizontal asymptote, actually horizontal, not vertical. Vertical, we have to do something else. Horizontal asymptote at y equals 0. Okay, or the x-axis. Okay, so if we look at number 1, square and square, oh wait, dang it, I lied. If they're the same, you take the coefficients as fractions, and it's y equal that. 1 over 1 or 1. So in our case, it's like 1 over 3. So our horizontal asymptote would be y equals 1/3. Okay, now if the number on top is bigger than the number on the bottom, then we have what's called a slant asymptote, and we have to do long division to figure that one out. That one's the best is to just graph it. Now if we have like the top that's smaller than the bottom, that's when it's the y equals 0. Okay. So our horizontal asymptote for 1 is y equals 1/3. If we look at number 2, our horizontal asymptote, we have both x's would be 1 over 1, so y equals 1. If we look at 3, it's not going to follow that case. But if we look at 4, we've got y equals 0 because degree of 1, degree of 2. Okay, so those would be our horizontal asymptotes. Okay, for 3, what we actually have to do is do long division. So we'd go negative 3x plus 9 goes into x squared minus 2x plus 0, essentially. Okay, say to get negative 3x plus 9 to match up to the x squared, we would have to times by a negative 1/3 x. Because negative 1/3 x times negative 3x would give us a positive x squared. The negative 1/3 x times 9 would give us a negative 3x. Then we change the sign and we add. So that becomes 0, which is what we want. Negative 2x plus 3x would just become x plus 0. So, horizontal asymptotes, as you can see, are not very fun. So how can this become just an x would be by timesing it by a negative 1/3. So that would give us a positive x minus 3, and we'd have a remainder of negative 3, which would be plus negative 3 over negative 3x plus 9, which we could simplify that to negative 1 over, well, positive 1 over positive x minus 3. Okay, that would be our slant asymptote, that linear equation right there. And really, we don't worry about this part. That's your horizontal asymptote. So y equals negative 1/3 x minus 1/3. Okay, so that's horizontal asymptotes. Now, to get vertical asymptotes, we need to simplify as much as possible. And then we take the denominator, once we've simplified, and use that to find our vertical asymptotes. So, using factoring, you'd use the box method, but you'd end up with x plus 4 times x plus 2 over, we could pull a 3 out of all of these. That'd be x squared plus x minus 12. So to get 12 would be 4 and 3, so it'd really be 3 times x plus 4 times x minus 3. Okay. Now, if you remember, we can cancel stuff out. And what that does is it creates a hole. Okay. If we went where 0 equals x plus 4 and solve for x, that means at x equals -4 we have a hole, but we're not concerned about holes right now, so we won't worry about that. Okay, so we are left over with that x plus 2 over x minus 3. So with that, the top will tell us where our x-intercept is. So we set it equal to 0 and we solve. So -2 equals x, so we have an x-intercept where x equals -2. And our vertical asymptote, we do the bottom one, x minus 3 equals 0. So we add 3, so we get x equals 3. So the line x equals 3 is our vertical asymptote. Okay? Now to find the last, the y-intercept, we would just take and plug 0 in for x on the whole thing. So that would eliminate all these x terms. So we'd have 8 over -36, which we could reduce to 2 over, if we divide by 4, 2/9. -2/9 would be 0. -2/9 would be our y-intercept. Okay? All right. So, quite a bit of work on these ones, aren't there? All right, so this one we can't simplify any further. So, to get the y-intercept, we just make the x as 0, so we'd eliminate. So -2 over 1, so -2. So for y-intercept would be 0, -2. X-intercept, we take the top, x minus 2 equals 0, solve for x. So we get x equals +2, so x-intercept would be 2, 0. Then the bottom, x plus 1 equals 0, would give us our vertical asymptote. So x would equal -1. So our vertical asymptote would be that line, x equals -1. Okay, so that one was a little more simple, not so bad. Okay, now let's do the next one. So we would simplify these ones, so we'd get x times x minus 2 over -3 times x minus 3. Okay, so for the we've got the horizontal, which is actually slant asymptote. So for the vertical asymptote, we can basically get rid of that and go x minus 3 equals 0, add 3, so x equals 3. So our vertical asymptote would be x equals 3. Okay, take the top, so we split it up, so there's 2 x-intercepts, which can happen. So we get x equals 0, so an x-intercept at 0, 0, which would tell us that's also a y-intercept, because it crosses at the origin. Okay, then we'd add 2, we get x equals 2, so at 2, 0, we also have another x-intercept. Okay, so our y-intercept, we'd make those equal 0, and we'd get 1 over 6 left over, so it'd be 0, 1 over 6. Okay, then we see if we can simplify. So I can pull out a -3, so we'd have x plus 1 over, so it'd be -3 times x minus 2. Oh, that's an x squared. So -3 times x squared minus x minus 2. Okay, factors would be 2 and 1, with 2 being negative, so this inside here would actually change to x minus 2 times x plus 1. So the x plus 1's cancel, so that actually would create a hole at x plus 1, so x plus 1 equals 0, which would subtract 1, so where x equals -1, there's a hole. And we could plug that in and find the y value for that hole, which we probably should do. So -1, actually, yeah, -1 plus 1 over negative 3 times negative 1 squared plus 3 times negative 1 plus 6. So it would be 0 over, and that would be positive 1, negative 3, minus 3 plus 6, so negative 6 plus 6, so basically 0. So at the point negative 1, 0, we have a hole in the graph, okay? Which you didn't ask for, but that's good to know, okay? But we're left with 1 over negative 3 times x minus 2. So there's no x-intercept because there's no x value here. So x-intercept is none. Okay. For the vertical asymptote, which is the last piece, we can get rid of that basically. X minus 2 equals 0. Add 2 to both sides. We get x equals positive 2. Okay, which we could then use that stuff to then graph it, or we could just type it into our calculator or Desmos and get your graphs that way as well. Okay, which is honestly what I would suggest. So I'm going to do these by hand so you can see how to do them. So first one, can't eliminate anything, so there's no holes. Horizontal asymptote, first thing I look at, same number here, same number on the bottom, degree, so I go coefficients 1 over 1. So y equals 1 is my horizontal asymptote, so I draw it. Y equals 1. Take the bottom, because I can't simplify anymore, set it equal to 0. Subtract 4, x equals negative 4. That is my vertical asymptote. So I go to negative 4, I draw a vertical asymptote. Okay, then I take the top, set that equal to 0 and solve. That is my x-intercept. So at negative 2, 0, we have our x-intercept, so it's right there. Okay, for y-intercept, I simply get rid of the x's, and I have 2 over 4, which is 1/2. So at 0, 1/2 is my y-intercept right there, which tells me my graph's going to look like this. And there we go for that first one. That one wasn't too bad, was it? Okay, fairly easy when we're dealing with them like that. Okay, so now number 6. Once again, highest degree, 2 and 2, so 1 over negative 1. So y equals negative 1 is my horizontal asymptote. And I've got to simplify these guys. Top, I can pull an x out, so I get x times x minus 4 over the bottom. It's got a negative out front, so first I would take out a negative, so it would be negative 1 times x squared minus 3x minus 4, which that would factor into x minus 4 times x plus 1. Now these x minus 4's cancel out, leaving me with x over negative 1 times x plus 1. Okay, so that means there's a hole. So x minus 4 equals 0, so basically x equals 4. So 4 and then some other number. Well, I plug 4 into these x values, that's where I find the y value. So I'm going to clear some space here. So to finish figuring out where my hole is, okay, I'm going to go 4 over negative 1 times 4 plus 1. So that would be 5, so negative 5, so negative 4/5. So at 4, x value 4 down negative 4/5, there's going to be a hole. So like right there, there's a hole. So I draw a circle there to represent that hole. Okay. Take the top, set it equal to 0. That's our x-intercept. So x-intercept at x equals 0, which should make sense that that's going to basically be our y-intercept as well, right? Because if we made those zeros, 0 on top would make it 0, so that's our x and our y-intercept, so 0, 0. Okay. Then, our vertical asymptote, we take the bottom, negative 1 times x plus 1 equals 0. Divided by negative 1 would do nothing, so that's kind of why you usually don't pay attention to that. So x equals negative 1 is our vertical asymptote. So -1. I draw my vertical asymptote. So this is going to have to come down here, go through the hole like that, and this side will go something like that. Okay? There's those ones. Okay, now let's take a look at these other two. So 7, no x on top, x on bottom means our horizontal asymptote is at y equals 0, which means we have no x-intercept. Okay, so we take the bottom here, set it equal to 0 for our vertical. Get -3x equals -12. Divide by -3, we get x equals +4. So that's our vertical asymptote. Okay, now we don't have any holes, no x-intercepts, so y-intercept. So it would basically be 1/12, right, if we got rid of that x, because x would be 0. So at 0, 1/12, we have a y-intercept, which tells us, oh, let's do that a different color. Let's actually try to hit that y-intercept. So this way and this way is what our graph is going to look like. Okay, alright, let's take a look at this last one now. This one's probably going to be an ugly one, because bigger on top than on bottom. So I have to do long division here. Okay, but first off, let's find the other stuff. So to factor that, we'd get x minus 6 would be 3 and 2, and it's -1, so x minus 3, x plus 2, over, pull out a -2, -2 times x minus 1. So we can't eliminate anything, so we have no holes. Okay, for our vertical asymptote, we take the bottom, x minus 1, set it equal to 0. Add 1 to both sides, we get x equals 1. So there's my vertical asymptote. Okay, then the top, there's 2 of them, so we split them up and set them equal to 0, so we have 2 x-intercepts, which is alright to have. Can't have 2 y-intercepts, but we can have 2 x-intercepts. So add 3, so x equals 3, and -2. So those are our x-intercepts, at -2 and at 3. Okay. Then y-intercepts, if we make all those x's zeros, we're left with -6 over +2, which would be -3. So y-intercept at -3. So right there, so you can kind of see now we just need to find that slant asymptote. To do that, we do long division. So I go -2x plus 2 divided into x squared minus x minus 6. To get -2x to become an x squared, we need to times by basically its opposite reciprocal in x. Because 1/2 times -2, well, -1/2 times -2 would be +1, x times x, x squared. Okay, 2 times -1/2 would be a -1x. So we change the sign and add them. Becomes 0, that also becomes 0. So that's pretty much our horizontal asymptote, 1/2 x. So we'd start here and we'd go down 1 to the right 2. So this light blue will represent our horizontal. So this would be our horizontal asymptote. So essentially our graph's going to go like this. And there is graphing our rationals, which, like I say, I try to use a calculator or Desmos, and that could help you with a lot of this stuff as well. But that's the main gist of things for rationals, and hopefully jog some memories, and there we go.